Good morning, students. Today is the lecture number 5, and the topic is errors in measurement. So, before getting into the deep details of this topic, I will be giving you a brief introduction on the errors. What are the types of error, and what are the the physical quantities which we measure in error. So, error, as we have already discussed in the previous lecture, that error is basically a deviation of the measured value from the true value of any physical quantity. That is, for example, let us say there is an object whose length is, let us say, 6.12 centimeter, and the length measured by any measuring instrument is, let us say, 5.80 let's say 5.82 centimeter. Then the deviation is how much? The deviation is equal to 6.12 minus 5.82, which is equal to 0.30 centimeter. So the error in this measurement is equal to 0.3 centimeter. I think this is a very easy definition, so we don't have to just discuss anything more than that. Second thing is the type of error. Types of error. I am taking this lecture because this has got a relevance with respect to your board examination. In the board examination, you might be asked a few questions. It can be in the form of a MCQs, that what are the different types of error, and means what is the instrumental error, what is the personal error, what is the random error. So these type of questions are generally can be asked in the board examination. However, in the this NEET and the JEE main examination, nothing much will be asked from this topic, except that you have to have a very good understanding of how to measure the different types of error. The different types of error means we will be discussing about it very shortly after the discussion on these types of error. So the types of error means basically the errors are classified as systematic error, and second one is called the random error. Now the systematic error is further. Systematic error again is of two types. The first one is the instrumental error, and the second one is the personal error. The instrumental error arises because of the measuring instruments, and the instrumental error are basically due to the zero error in the measuring instrument. We have already discussed about the zero error in the lecture number 3 and 4, and because of the calibration issue of that measuring instrument. Calibration means calibration issue means that measuring instrument has not been calibrated for a very long time, or if it is calibrated, it has not been done properly. So these are the basically two main reasons for the instrumental error. For the personal error, the personal error arises because of the carelessness of the person who is taking the measurement. If it's not, I would just try to explain this this error with the help of one example. That is, if someone is taking the reading, keeping his head in a slanted position like this one. So what will happen that the measured value will definitely have a deviation from the true value. Whereas if his head is straight like this, then the measured value will be equal to the true value, or it will be very very close to the true value. So the personal error arises because of the carelessness of the person who is taking the observation, and more often whenever a person is taking the readings, his head position is of prime concern. Sometimes many of the people, they are taking the readings, they are not keeping the head straight, they are keeping the head like this in a slanted position. So when you are seeing the reading in this way, definitely you will be having a deviation because of the parallax this effect. Okay. So personal error is because of the carelessness of the person who is taking the measurement. Instrumental error is because of the zero error and the calibration issue. Now third one is the random error. The random error, as the word suggests, or as the word tells us, that this error is a random error and it happens irregularly. And the random error basically arises because of the fluctuation in the experimental conditions, like the fluctuation in the temperature. There can be a fluctuation in the voltage supply, and it also happens due to the personal error also. So these are some of the factors which generate the random error, and the errors are classified as systematic error and the random error. In the systematic error, these are the two important errors which generate the error in the measured value. And in the random error, as I have just told you, that it is because of the fluctuation in the experimental conditions. So this is a very very short description of the error and the type of the errors. Now we will straight away come to the measurement of error. This is an important topic from the point of view of the board examination and also from the point of view of the NEET entrance examination. Measurement of error. In this topic, the first point which I would like to discuss here is the least count error. The least count error, as the name suggests, is because of the resolution of the measuring instrument. What is the meaning of the resolution of the measuring instrument? That is the least value which we can measure with a particular measuring instrument. Let us say, I will just try to explain this with the help of an example. Let us say there is a physical quantity whose length is let us say 6.84 centimeter. Okay. Now I am asked to measure this physical quantity with the help of a measuring instrument whose least count is, say, 1 millimeter. Okay, I have been given a measuring instrument whose least count is 1 mm. Now, with the help of this instrument, I will measure the length of this physical quantity. Now, my question here is, can we measure the true value of this physical quantity with the help of this measuring instrument or not? So the least count means it is the minimum value which we can measure with the help of that instrument. Now here you see this, the length, the true value is 6.84 centimeter, which I can write it down as 6.8 centimeter plus how much? 0.04 centimeter, or we can also write it down as 6.8, let's say it is 68 mm plus 0.4 mm. Okay, I have just broken down this length into mm, and I have done it in order to explain you whether we will be able to measure the true value of the this physical quantity with the help of the measuring instrument which I have been given, which is having a least count of 1 mm. So the true value of this physical quantity is 68 mm plus 0.04 mm. The least count of this measuring instrument is 1 mm. So the least, if so this value can easily be measured without any problem, because it is 68 mm, and it means that 68 divisions on that measuring instrument will be equal to this reading. But what about this? This is 0.4 mm, whereas the measuring instrument can measure 68 mm and the least count is 1 mm, so the next reading which it will measure will be 69 mm. It cannot measure 68, that this is equal to 68.4 mm. So it will not be able to measure this reading because the least count is 1 mm. What it can do is it will measure 68 mm or 69 mm. So, now if the least count was, let's say, if 0.1 mm, then it means that one division of that measuring instrument is equal to 0.1 mm. So if the least count was 0.1 mm, then we could have easily measured the length of that particular physical quantity without any problem. However, since the least count is 1 mm, therefore with the help of that instrument we will either measure 68 mm or 69 mm. So when now I have been given, वो एक इंस्ट्रूमेंट दिया गया है मेरे को, now मैं क्या करूँगा, उसको मेजर करूँगा. So मैं कहूँगा भाई इसकी जो वैल्यू है, the value of that physical quantity is approximately 68. I will say either 68 mm or I will say it is 69 mm. Because I cannot measure 68.4 if the least count is 1 mm. So what will be the error? Error is equal to the measured value, the difference between the measured value and the true value. So here, if I say that the approximate value of this measurement is 68 mm, then then the error will be equal to the difference between the true value, that 68 mm is equal to 6.8 centimeter. So which the error will be equal to 6.84 minus 6.8, which is equal to 0.04 centimeter. However, if I say that the value of this physical quantity is 69 mm, then what will be the error? The measured value, that is the true value, the measured value, let's say it is 69 point, let's say 0 minus 60, this is equal to 6.9 centimeter minus 6.84 centimeter. So this will be equal to how much? 0.0 centimeter. Okay, so the error we can get two errors. One error when I say that this value is 6.8 centimeter. If I say that the length of that physical quantity is approximately 6.8 centimeter, in that case the error is coming out to be 0.04 centimeter. But if I say that the length of that physical quantity is equal to 6.9 centimeter, then the error will come out to be 0.06 centimeter. Second thing, if I say that let us say I have been given another instrument which is having a least count of 0.1 mm. 0.1 mm. 0.1 mm means उस स्केल के ऊपर, उस मेजरिंग इंस्ट्रूमेंट के ऊपर एक डिवीजन की वैल्यू 0.1 mm है. So 0.1 mm है. So now 684 centimeter is equal to 68.4 mm. ठीक है. So with the help of that instrument we can easily find a true value, because one division is equal to 0.1 mm. तो ये 68 mm तो हमने मेजर कर लिया, which is not a problem, and the remaining 0.4 mm is equal to 4 divisions of that measuring instrument. So this measurement can easily be measured by that particular instrument without any error. Definitely there can be an error, because a person who is taking the reading can create the error at the time of observation also. But if you are not careless, and if you are taking the readings properly with your head in the right position, then you can definitely get the true value with the instrument which is having a least count of 0.1 mm, because one division is equal to 0.1 mm, 0.4 mm is equal to 68 mm plus 0.04 mm. This is equal to what? This is equal to 68 mm plus 0.4 mm. So this can easily be measured by that instrument, and 0.4 mm can also be measured because one division of that instrument is equal to 0.1. So four extra divisions will be 4 divisions on that instrument is equal to 0.4. So we can easily measure the true value. So in that case the error can be 0. But in this case it will never be. You cannot measure this 6.84 centimeter with an instrument having a least count of 1 mm. So I think that with the help of this example you must have understood what is the least count error, and what are the limitations in the measurement of any physical quantity which is with respect to the least count of that particular instrument. So now let's move on to the next topic. The next topic is see here one was the least count error. Least count error. The second topic is now the absolute error. The third one is the mean absolute error. And the fourth one is the relative error. And then comes the percentage error. So here we have discussed about this about the least count error. Now the second point is the absolute error. Now I will again try to explain this with the help of an example. Let us say there is a physical quantity which is having a length of 5.24 centimeter. This is the length of a physical quantity whose length is 5.24 centimeter. We know that this is the true value. This is the true value. We know the true value of. Now, I am given a measuring instrument and I measure this length of this physical quantity. Let us say the first length. Let us say we can make it as A1 is equal to 5.2 centimeter. Let us say I again measure the length of that physical quantity, and this time the reading comes out to, let's say, 5.3 centimeter. I again measure the length of this physical quantity, and let us say it is coming out to 5.1 centimeter. Okay, so absolute error pertains to each and every measurement. That is, absolute error will be is given by, that is written by delta A1, and this is mod. Mod means mod means that I will just try to explain why it is mod. So this will be equal to A1 minus true value. Okay, A1 minus true value, or you can also write it as true value minus A1, because error is what? It is a deviation. We are measuring the deviation of the measured value from the true value. So you can write it down as true value minus A1 or A1 minus true value, because this is a mod. Mod is written because sometimes these absolute error may contain a minus sign. Minus sign कब होगा? जब true value की value measured value से ज़्यादा है, तब आपका माइनस साइन होगा. तो हमें क्या करना है? बिकॉज एरर इज बेसिकली अ डिविएशन है, तो वो आपकी ट्रू वैल्यू से कम भी हो सकती है और ज़्यादा भी हो सकती है, बट इट इज़ अ डिविएशन. सो यू डोंट हैव टू कंसिडर द माइनस साइन, एंड बिकॉज ऑफ दैट वी जस्ट say that delta A1 is equal to the mod of A1 minus true value. बिकॉज जब मॉड लगाएंगे इसका मतलब ये कि अगर इसकी वैल्यू माइनस भी आ रही है तो यहाँ पर आपको पॉजिटिव नंबर ही मिलेगा. सो सिमिलरली नाउ डेल्टा A2 क्या है? दैट विल कैन बी रिटन एज A2 माइनस ट्रू वैल्यू, एंड डेल्टा A3 इज इक्वल टू A3 माइनस ट्रू वैल्यू. ठीक है, ये आपका जो है आपका ये आ जाएगा. सो दिस इज द एब्सोल्यूट एरर ऑफ द measurement A1. This is the absolute error of the measurement A2, and this is the absolute error of the measurement A3. Okay. Now आप यहाँ देखो, अगर यहाँ पे 5.24 है, ये आपका, हाँ, अभी एक और चीज़ आपको मैं लेट्स से मैं कहता हूँ, हाँ, इस केस में आप देखो ध्यान से, यहाँ पर क्या है कि A1 इज 5.2 माइनस ट्रू वैल्यू, यहाँ पर साइन आपको नेगेटिव आ रहा है, नेगेटिव आएगा, बट हम यहाँ पे क्या लिखेंगे? यहाँ हमारी वैल्यू आ जाएगी 5.2 माइनस 5.24, सो विच इज इक्वल टू हाउ मच? 0.04 सेंटीमीटर. वैसे तो ये माइनस में आएगा, बिकॉज अगर आप इसको माइनस करो 5.20 5.24, तो ये आपका आ जाएगा माइनस में. ठीक है, बट हम इसको जो है कंसिडर करेंगे पॉजिटिव, बिकॉज एरर इज अ डिविएशन एंड नेगेटिव साइन डजंट हैज एनी रेलेवेंस. यहाँ पर आपका क्या आएगा? यहाँ पर होगा 5.3, तो ये आपका हो गया 0.06, और यहाँ पर कितना आएगा A3 में? ये है आपका 5.1 है, सो हो गया 5.24, दैट इज इक्वल टू 0.14 सेंटीमीटर. So these are the absolute errors of these three measurements. Okay. Now this is the calculation when the true value is known. But if I am given a physical quantity and I am told to measure this with the help of an measuring instrument, and I don't know the true value. So so how we will find the absolute error? So in that case, what we do is we will definitely, now in this case I have taken 3 readings. So what we will do is I will take as much reading as possible when the true value is not known. I can take 5 readings also, I can take 10. तो जितना ज़्यादा आप रीडिंग लेंगे उतनी ज़्यादा आप जो है ट्रू वैल्यू के पास पहुँचेंगे. ठीक है. But one more thing, the true value is also dependent on the resolution of the measuring instrument. That is a very very important factor which you have to keep in the mind. So हम क्या करेंगे, हम जो भी रीडिंग्स लेंगे, बिकॉज हमें ट्रू वैल्यू पता नहीं है, हम कई सारी रीडिंग्स लेंगे एंड देन वी विल टेक आउट द मीन ऑफ दोज रीडिंग्स. दैट इज कॉल्ड द ए मीन, एवरेज, विच विल बी हियर इज इक्वल टू A1 प्लस A2 प्लस A3 डिवाइडेड बाई 3. So we will get a value which is equal to how much? If we just add it here, 3 to 5 and 6, 15.6 divided by 3, so which is equal to 5.2. So this is equal to 5.2 centimeter. Now this average value will now be considered as a true value in order to find the absolute error. Okay? So हम यहाँ पे क्या करेंगे, अब हमारा इसका वैल्यू क्या हो जाएगा, अब आप ध्यान से देखिए हियर, यहाँ पर ये हो जाएगा अब आपका, दिस विल बी नाउ, दिस विल बी रिटन एज A minus A mean, A mean, A mean. Okay? So अब इसकी वैल्यू कितनी हो जाएगी, A1 minus A mean, A1 minus A mean. Here you will see that we have measured its value is 0. The absolute error is 0. In this case is equal to 0.1 centimeter, and in this case it will again be equal to 0.1 centimeter. Okay, now the values have changed because we have here considered the measured value, we have considered the average of the measured value as the true value in order to calculate the absolute error. And this method is followed when you do not have the true value of any physical quantity. In that case, this method applies. You have to find the average value of the measured value, and that is considered as the true value. So now we have found the 3 absolute errors like this, that is equal to 0, 0.1 and 0.1. Okay. So what will be the mean absolute error? Mean absolute error will be equal to, that is mean absolute error will be equal to delta A, you can write it as mean, which is equal to 0 plus 0.1 plus 0.1 divided by 3. So this is equal to 0.2 divided by 3. So this is equal to 0. How much? This is equal to 0.6 centimeter. Okay. So this is the mean absolute error, this one. Absolute error is this one, which we have just calculated here. This is the mean absolute error. Now, what is relative error? Relative error. So, relative error is equal to mean absolute error divided by the true value or a mean, that is the mean of the measured value. This value will be taken if you know the true value of any physical quantity. If you do not know the true value of the physical quantity, then we have to take the mean of the measured value as we have just as I have just explained here. So relative error is equal to the mean absolute error divided by the true value or the arithmetic mean value. And so in this case, what will be the relative error? So relative error will be equal to 0.06 and divided by what is 5.2. So you can just find the answer. That is 0.06 divided by 5.2. Okay, so this will be the relative error. And now the last one is the percentage error. So percentage error में कुछ नहीं करना है. Percentage error is equal to relative error, this relative error into 100. So if you just multiply it by 100, so this the percentage error. The percentage error will be equal to this into 100, or we can say that this will be equal to 6 divided by 5.2. Okay. So in this way we find the different these are the different types of errors which are important from the point of view of your board examination also, and from the point of view of your NEET examination. And definitely a couple of questions are definitely asked in means you will get a question from this topic in the board examination also, and you will also get the question in the NEET examination. Okay. So summing up, the absolute error is the difference between the measured value and the mean value, or the measured value and the true value. The mean absolute error is the mean of the absolute error of the different measurements which you have taken. So we have found the mean absolute error. Percentage, then we have this relative error can be found with the help of this formula, that is the mean absolute error divided by the true value or the mean value of the measured readings. So here the value which we have taken means the arithmetic mean of these three readings was equal to 5.2. So based on that, we have calculated the relative error as 0.06 divided by 5.2, where 5.2 is a mean. And the percentage error is equal to 0.06 divided by 5.2 into 100. Okay, so this becomes the percentage error. So these are the 1, 2, 3, 4, 5. These are the 5 types of errors which are important for you from the board and this NEET entrance examination, from the point of view of these two examinations. And in the next class we will try to solve a couple of questions from this topic. So the next lecture, that is lecture number 6, will in that lecture we will try to solve a couple of questions, and thereafter we will move on to the next topic in the errors in measurement, that is the topic of combination of errors. So thank you very much for your time, and I just want to again emphasize on two things. First thing is that everyone should have a very good command over the conceptual physics in order to solve any sort of problems, because that is the first hurdle which most of the students face. So you have to be very, very strong in the conceptual physics. When your concepts are clear, then it is only the then you have to put in a lot of hard work in solving as many questions as possible in the different topics, and definitely this is going to take a time. The most important thing is that you have to have a good solid foundation on conceptual physics. So this is what I am trying to focus on, and that is why I am delivering these lectures in such a way that it becomes easier for you to understand the concepts of physics in each and every topic. Now, if you have any questions, you can directly contact me at my mobile number, that is 9911079547, and that's my email address is bachhil.assish@gmail.com. So suggestions are also welcome. You can put across your suggestions regarding the deliverance of my lectures, and you can also contact me for any queries related to the difficulty in solving the numerical problems. If you have any problems related to the if you are not able to understand any concepts in any of the chapter, then I am ready to help you out. So thank you very much for your time. Have a nice day, and the lecture number 6 will be uploaded very, very shortly. Thank you very much.